Hello guys, we are still solving questions on solutions to homogeneous differential equation. This is our second example on that. The example says we should solve x power 4 plus y power 4 dx plus 2x cubed y dy equals 0. Solution. We were given first of all, let's make dy dx the subject from this. So in that case, we are going to have 2x cubed y dy equals negative x power 4 plus y power 4 dx. So in that case, our dy ds equals negative x power 4 plus y power 4 on 2x cubed y. Now, when we try to verify whether this is homogeneous or not, you can see that lambda power 4 can be factorized out, and then over here too we are going to have lambda power 3 lambda, and that will give a lambda power 4, and that will also come out. When you apply the law of indices, you are going to get lambda power 0, and hence it is homogeneous differential equation. Since we have been able to verify that it is homogeneous differential equation, the next thing we said is to what? Transform this equation in terms of x and u. Let's y equals ux. So our dy dx becomes x power 4 plus ux power 4 all on, let me attach the negative to this, 2x power 3 u. So simplifying, we are getting x power 4 out, 1 plus u power 4. So we factorize the x power 4 out, and over here too we have x and x power 3, and that also give us x power 4 negative 2 u. Cancelling out, our dy dx is now 1 plus u power 4 on negative 2u. Let's label this as our first equation, that's equation 1. From y equals ux, let's differentiate through this. Let's differentiate y with respect to x. Now remember that u2 is a variable of x, so differentiate the x with respect to x, and that will give us u, and differentiate the u with respect to x, and that will give us x du dx. Let's label that 2 as equation 2. So you can say that equation 1 equals equation 2, and that gives us 1 plus u power 4 on negative 2u equals u plus x du dx. So grouping the u's, we are getting, moving this to this side, I have 1 plus u power 4 on negative 2u minus u equals x du dx. We had 1 plus u power 4 on negative 2u minus u equals x du dx. So simplifying, first of all, let's multiply through by this through by negative. That will be negative 1 minus u power 4 on 2u minus u equals x du dx. LCM for that side is 2u. So in that case, we are getting the same thing, 1 minus 1u power 4, and here we are getting minus 2u power 2 equals x du dx. At this stage we can separate the variables. So separating the variables, we're going to get dx on x equals, then this one too will give us 2u on, let's rearrange it from the highest power, negative u power 4 minus 2u squared minus 1 du. Apply the integral to both sides, taking the right hand side, and that is and factoring the negative out, we will be getting negative integral of 2u on u power 4 plus 2u squared plus 1 du. And here, let's try to factorize the denominator. So we can easily break this one down. So breaking this one, we can get u squared plus u squared plus 1. U squared plus u squared will give us the same thing, 2u squared. Negative integral of 2u on, and group it into 2, we can factorize u squared out. So u squared out, here we are going to have u squared, and here is plus 1. And over here too, 1 is common, plus 1, u squared plus 1. And of which we are going to get 2u on u squared plus 1 plus u squared plus 1 du. This and this are the same, so we are going to have 2u on u squared plus 1 all squared du. Let w equals u squared plus 1. So now let's differentiate w with respect to u. So the w equals 2u du. In the du, the subject, we are getting du equals dw on 2u. So from negative integral of 2u on u squared plus 1 squared du, substituting the parameters back, we are getting negative integral of 2u on, the whole of this is w, so that becomes w squared. Now du is dw on 2u. So you can see that this cancels this, and hence we have negative integral of 1 on squared dw, which we can also write as, so integrating, we have a negative w negative 2 plus 1 all on negative 2 plus 1 plus c. When we simplify, we are getting negative w negative 1 on negative 1 plus c, and that will be w power negative 1 plus c. But w was u squared plus 1, hence it becomes u squared plus 1 power negative 1 plus c, which is also equal to 1 on u squared plus 1 plus c. So from integral of the x on x equals integral of 2u on negative u power 4 minus 2u squared minus 1 du. This is ln x, then let's add ln c to it, equals, and the whole of this, we had 1 on u squared plus 1, but we also know that y equals ux. So finding u becomes y on x. So let's substitute. Let's simplify this side. This side will give us ln cx equals, and over here we're going to have 1 on y on x all squared plus 1, and we are going to get in cx equals 1 on y squared on x squared plus 1, which we can simplify the denominator over here. That will give us ln cx equals y squared plus x squared on x squared. The answer becomes cx equals e power y squared plus x squared on x squared. So that is that for the solution to this problem. Thank you very much for watching. Please share.